Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate machining this part using mainly iMachining and also HSS to finish off specific areas which cannot be done in your typical 2.5D operations. In this part, as you see on the screen, it's mounted on a mounting plate on the machine itself, held by 4 screws. Other operations that we'll be using here as well will be drilling operations, and we'll also be using the chamfering option in our profile operation to complete the part. Now, let's first take a look at the part itself that we have on our screen, and the stock and the settings as well. If we take a look at the stock itself is a 3D block with the holes already in them. If I were to open up the stock and click on Show 3D, you can actually see the stock itself as shown over here with the holes in them. That's the actual stock. Now, if we were to go into our CAM part settings, you'll see that I have defined my iMachining data, and that will be working on 6061 aluminum, and we'll be working on level 6. In addition to this, we're also mounted on a fixture, on this plate fixture that will be mounted directly on the machine table itself. If we go into our setup, you can see we have our plate fixture as shown over here if we do the preview, and we also show exactly what the height will be of the 0 point to the table itself. Now we can also see that I've set the part up with different configurations where I can have it showing it with the stock and the mounting plate or on its own. Now what I'd like to do actually in the part, the machining I'd like to do is as follows. First, I'd like to work around the part itself, milling out all of these areas over here. But since I don't want to mill out these areas where it's being held down with the screws, so I want to actually mill a slot in these areas as well as over here to go around the part. In addition, we also have this edge over here, which can be done using the HSM operations in order to finish off those edges over there. Now let's start with our first operation. The first thing I'd like to do is remove the excess material that we have on top of the stock itself to get it down to the 0 level. For that, I've used the option of face mill. If I were to open up the operation of face mill, you can see my geometry is around the stock itself, and that I'll be using a 100mm face mill tool. The levels are set as the upper level being the top of the stock itself, and the face depth is up until the edge of the part itself, the top face of the part itself, which is a 0.5 millimeter down from the top of the stock. If I were to go into my technology, I'll be working with the technology of hatch, going back and forth on the part itself. Since the part itself has a width of over 400 millimeters, I have to do this going back and forth on the part. If we have to take a look at our simulation, you'll see that my tool comes down, goes across the part, and mills off the excess material that we had on the top of the part itself. The next operation, I'd like to machine around the outside shape of the part itself. To do this, I'm going to be using iMachining. However, when I do the outside shape, I'd like to actually mill in the way I am showing it to you right now, going around this edge over here without machining this area over here, as this area is actually being used to hold down the part itself. If we take a look at the bottom of the part, you'll see we also have excess material which allows me to actually hold on to the part. So in order for me to create the geometry around the part over there, I use some aid of creating a sketch around the part itself. If we were to take a look at the sketch that helped me create the geometry, and I'll put it in the top view so we can see it a lot better, you can see that my sketch includes an area over here around the outside boundary of the part itself, which is actually going around over here, and the actual part itself, a sketch of the outside of the part, allowing for a pocket type of geometry to be created over here. So if I were to go now into the operation itself that I created in iMachining, we can take a look at the geometry itself. And as you can see, we have our first chain on the outside of the part itself, where this edge and this edge, as well as these edges in these corners over here, are marked as open, and these left is closed, so it doesn't go past this area over here, only works within over here, and enters from these areas over here. And the second chain of this geometry is the one on the part itself. Now, the tool that I will be using will be a 16 millimeter end mill that has 3 flutes to it and a cutting length of 32 millimeters, staying out of the holder of 70 millimeters, as I have to go just over 60 millimeters in depth on the part itself. My upper level is 0, the top, going down to a depth of 60 millimeters plus another millimeter in the delta to go past the edge. Now, going down to this depth will allow for these screws over here to still hold on to the part, as I do still have excess material on the bottom over here. So the part will not be broken off, and I'll be able to actually machine the part all around to its full depth. Now let's go into our technology wizard of the iMachining, and you'll see first of all I'll be working at level 6, but not only am I working at level 6, since this is a tool specifically made for aluminum, if I go into my modified cutting conditions, you'll note I'll be working in turbo mode as well. The cutting conditions, level 6 and in turbo mode, will actually allow me to cut in this particular case with an RPM of over 9,000 revolutions per minute, with a feed averaging of over 6,800 millimeters per minute as well. The step down being broken down automatically into 3 steps on the part itself. Let's take a look at the simulation. And as you can see, the tool goes down. Now let it run, milling out the part itself on those edges around the edge of the part itself, as shown over here, and leaving this excess material over here for the screws to hold down the part. Now, the iMachining actually makes it working actually very efficiently inside those slots. If I were to look at it in the top view and show the actual tool path itself, you can see that it's taking the tricordial path around through the slots itself, and also cleaning off the corners over here using the tricordial tool path for those corners. Now, in my next operation, I've actually done the finish iMachining of the outside shape itself. If I were to go into the operation itself, you can see my geometry in this particular case is just the outside walls of the part itself. And I've just given it a defined offset from the geometry of 0.24 millimeters, which was the actual material that was left over from the rough cut. The tool will be the exact same tool I've used in previous operation, as this tool is also good for finishing. And if I go into my technology, you'll see that I'll be working in the iRest data, where I have the previous tool diameter of 16 millimeters and a previous wall offset of 0.24. If I have to take a look at the simulation now on this part itself, you'll see that the tool actually goes down, finishing off the wall and working only on the wall to the bottom. You can also note at the bottom of the part that we still have the excess material holding the part onto the fixture itself. Now, my next operation, I'd like to finish work on this step over here. So for that, I've also used iMachining. Let's just first put the part inside the configuration of standard so I can actually see the part itself without the fixture or the stock around it, making it easier for me to work on. And if we take a look at the operation itself, you can see that the geometry is made of two chains, one going around over here, having this edge marked as open, and the same thing on the other side, going around this area over here, and with this edge open over here. The tool in this case will be a 12 millimeter end mill that has 3 flutes and has a cutting length of 24 millimeters. The depth of the part goes down to this floor over here. So now if I go to my technology wizard, since this can be done in one step, it will do this entire area that has to be machined in one step. Again, we'll be working machining level 6 in turbo mode. Again, looking at our simulation, you can see, now start off going one step at a time. It'll work in that area doing a trochoidal step on the edge itself, working its way towards the back wall over there. It'll finish off on this side as well as on the other side as shown over here. Now for the finish cut, all we did was use the exact same operation but using the finish option for the iMachining as shown over here. And if I go into my technology, you'll note that my iRest data is based on the previous operation using the exact same geometry as I had before. Now, we still have one area that I still like to use iMachining for, and that is these pockets around over here. So for that, again, we have our geometry of those pockets over there. If we take a look at the operation itself, again, we have our geometries, we have our tool, our levels. In this particular case, our upper level is this surface over here, going down to the very bottom of that pocket. A total of 20 millimeters, with an extra millimeter to pass the actual edge of the part itself. If we take a look at the simulation itself, you'll see that it's doing a morph spiral cut inside the pockets itself, as shown over here. And where it can't do the morphing anymore, it just finishes off with the trochoidal cuts inside the pocket itself. And it does it the same on the other side. Also note the entrance into the pocket itself is done automatically with the helical cut into the pocket itself. Now, of course, after we've done the regular roughing cut for the iMachining in those pockets, we also have a finish cut done exactly the way the previous finish cut was done. Now, next, I'd actually like to drill out these holes over here. So for that, we used our drilling operation. And since these holes, if I take a look at them, are a diameter of 20 millimeters, what I decided to do over here was to first drill this out up until 18 millimeters and then do a profile operation to finish off those holes itself. So if we take a look at this set of 3 operations over here, first drilling the holes using a spot drill, and if we take a look at geometry, I've chosen those 5 holes, and my tool is a 16 millimeter spot drill going down a total of the tip of the tool going down 7 millimeters into the part itself. My next operation, we also had a drill operation based on the original drill operation, but this time I have a tool of 12 millimeters going down 60 millimeters into the part itself. And in my next operation, my last drilling operation, I worked on the exact same hole, but this time I enlarged the hole with an 18 millimeter drill going down again to the same depth. In my profile operation, I've chosen the geometry to work around those holes over there. That's the actual geometry. Looking from the top, you can see it here very well. My tool in this particular case will be a 12 millimeter end mill. My level's going all the way down to the bottom of the part. In my technology, I'll be doing first a rough cut, leaving a 0.5 millimeter of material on the edge, and then also doing a finish cut on the part. Now let's take a look at the link. What I'd like to do in the link, since I already have this milled out over here, I'd like to have the tool go down through the center of the hole and then move to its position. So in my lead in as well as my lead out, I have first of all approaching the material with an arc, but not only approaching from the arc, I wanted to actually start from the center of the circle geometry, going down exactly in the center of the hole itself. If I were to take a look at the simulation, you'll see that the tool goes down in the exact center of the hole itself and then works off to the side. And this is done for every single one of the holes. And if we zoom in just to the tool pass, you can see that it goes every single time after it exits with the arc, it goes back to the center of the hole itself. Now, before I continue to my next operation, I'd first like to take a look at all of the simulation I've done up until this point. So I'll mark off the operations that I want to see the simulation on. And in this particular case, I like to use a simulation of machine simulation, which allows me to see the simulation exactly the way it will be done on the machine itself. Now, as we start the simulation, you'll see the tool was face milled off on the top, and now we have the iMachining working inside the part itself, inside those edges as shown over here. This is exactly the way it'll work on the machine, and you can see those grooves being put in around the part itself, going up until the actual part as shown over here. Now when it finishes this level as shown over here, it'll then go and do the finish cut using the iMachining. Now working with iMachining in these areas over there and inside these pockets over here, then working the holes and milling out each hole to the very bottom as for in the operation itself. Now, if we take a look at the part the way it looks right now, everything seems to be finished on the part except for these corners over here. This corner still has to be milled out. However, this cannot be done using the 2D operation for those edges. For that, we're going to use HSS to complete those corners. So let's take a look now at the HSS operation that I've created over here. I'll open up the operation. I've used the option of parallel to curves. If I were to take a look at my geometry, you'll see first of all the surfaces that I want to machine. As you can see, I've picked these forced surfaces. Note also that it goes around to the very bottom. Now, that was my drive surface, where my edge curve were these edges over here. So it works parallel to those edges as it goes down the part itself. The tool in this particular case was a 12 millimeter ball end mill. Let me go into gouge check. Since I want to prevent the tool itself from actually going underneath over here, since it can't work over there, I've chosen the option of gouge 1, and I've made sure that my holder or arbor or tool shaft does not hit the drive surfaces. Now, besides doing that, I've also gone into my transformation area. In the transformation area, I've done, first of all, multi-passes, since I have excess material on the edge over there. Plus, I've given it the stock definition, allowing it to work only in the areas where there's stock. In other words, to avoid any air cuts. If I were to show you the 3D of the stock itself, you can see that this edge has to be machined, so it will only work only where this material to be taken off. If we were to take a look at the simulation itself, you'll see that the tool will go down and work in each area, first doing a rough cut and then finishing off each area itself as it goes down on the part. And as you can see, it finna give a perfect finish on the part itself, where the tool only going down to this area itself, finishing it off on this side. Now that we finished the actual machining that we had to done from this side, we still have the chamfers that have to be put on over here. In this particular case, we have the chamfers over here. We have another chamfer over here. Plus, I'd also like to break the edges around the parts over here as well as the holes. So first, we'll take a look at this operation that I've done for chamfering, working on these edges around over here. The tool will be a 10mm chamfer drill, and as for my levels goes, starting from the upper level of 0, going down to a depth of 1mm as picked off from the edge itself. Now, in my technology, if we go into my area of chamfer, you'll note that I'll be using the 1mm diameter of the tool to cut the part itself, and the depth that it'll actually go is automatically calculated from the tool's angle plus the cutting diameter as well, in order to give me that 1mm chamfer that I asked for. If we were to run my simulation, you'll see that the tool will go down and give me that chamfer that I asked for on the part itself, both on this edge and on this edge over here as well. Now, in my next operation, I've also done a chamfer operation, but this time I'll be working just on the holes itself. And if I were to open up the operation, I'll be using, again, the chamfer drill as I had before, the exact same tool. Levels, starting again from the top, but this time just breaking the edges with 0.2mm. And in my technology, again, I have the exact same thing I had before, using the cutting diameter of 1mm. Again, taking a quick look at the simulation, you can see that the tool went down and worked on these edges over here. As for the rest of the part, we also created a chamfering operation for these edges over here and these edges, as well as this edge over here. So every single edge was covered. Every single edge was covered to leave no sharp corners on the part itself. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.